Hey everyone, so this is my Physics 1 Lab 3. My name is Ansley Hightower. Oh my gosh. Okay. So the purpose of the experiment was to just observe the gravitational force and net force and then use those to calculate mass and velocity. So some fundamental physical principles that we use for gravitational force, momentum equals mass times velocity, and then net force is equal to the change in momentum over change in time. And so the main lab result, um, we got the mass of the black hole using gravitational force, which I show on the screen. And then I fiddled around with the initial velocity of the spaceship to get it close to the black hole without crashing. And so I put those on the screen as well. So some physics principles that we use, Newton's second law, which is force equals mass times acceleration. It's always important to use. And then momentum is equal to mass times velocity, and net force is equal to change in momentum over change in time. And then gravitational force of like planets and stars, which is F of G is equal to big G times M1, M2 over R squared. So big G is just a constant, 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. And then we use the position update formula. So the system in part 1 was the star, and the surroundings was the black hole. And then in part 2, the spaceship was the system, and then the planet and black hole were the surroundings. And so the initial conditions, we were given the mass of the star and the time between data points, and then the black hole mass was basically an initial condition for part 2. It wasn't in part 1, but we calculated that and had to input it into the code for part 2. So I consider that an initial condition. So the computational model for part 1, we input the star's mass and then converted the day into seconds. So 1 day into seconds, which is 24 times 60 times 60. And then we used just the momentum formula, momentum equals mass times velocity, and then calculated the initial or the change in momentum and the change in velocity, and then inputted like position of the star and the net force and the mass of the star into the gravitational force equation that I showed earlier to calculate the mass of the black hole. And then it outputted several different masses. So then we averaged those to get just the average mass of the black hole. In the second part, we were trying not to crash into the black hole. So we had to just play around with the initial velocity of the spaceship so that it would get close to the black hole but not crash into it. So on the screen are the initial velocities that I got in the X and Y direction in meters per second in the green at the top there. And then we use just gravitational force again on the planet and of the ship on a planet, to just calculate like orbital period and orbital speed, which is what the code outputted. Yeah, it's the main. Okay, so potential error, really error in this lab would just be coding, correctly translating physics formulas into code or misinterpreting values that the code outputted. The what does it mean? It was asking about rate of change of momentum and net force, and they are the same mathematically because force is equal to the rate of change of momentum, but they are not the same more abstractly because change of momentum is more easily calculated, I would feel, by humans, just because you could easily determine like change in speed or change in velocity and change in time. So then you could calculate change in momentum. But then you need that to calculate force. So it's more easily calculated. Momentum is more easily calculated than force. And then what if I played around with the velocity in the X and Y directions and I made them both more negative, trying to be able to orbit the black hole, but all I was really changing was the trajectory of the spaceship velocity. It was just changing that line, which is the pink line, but the blue orbit wasn't changing. And I was just making the pink line just straight, or just it was changing and it wasn't what I wanted to do. So I still can't figure that out, but It's okay. So in conclusion, to calculate the mass of the star, the gravitational force formula must be rearranged. And the net force on the planet is used to determine the planet's velocity. And then when determining velocity of an object in space, forces from objects in the surroundings must be taken into consideration. Thank you.